Our world is a tapestry woven with the threads of history. We often imagine the story of humanity as a simple, linear progression, a steady march from primitive beginnings to our current technological age. Yet, scattered across the globe, lie extraordinary artifacts and structures that tell a different story. They whisper of forgotten knowledge, of moments in our deep past when our ancestors achieved feats that, even today, we struggle to fully comprehend. These are not mere curiosities, they are profound challenges to our understanding of history, suggesting that the path of human progress may have been far more complex, with peaks of astonishing brilliance followed by periods of inexplicable decline. Consider a simple iron pillar in Delhi that has resisted rust for over a millennium, or think of immense stone blocks cut and fitted with a jeweler's precision, long before the advent of lasers and diamond-tipped saws. These creations are not just impressive for their time, they are impressive by any standard, compelling us to ask a fundamental question. How did they do it? The answers are not readily available, lost to the sands of time, leaving us with a sense of wonder and profound respect. And as we examine these clues, from the intricate gears of an ancient computer to the enduring strength of Roman concrete, we are constantly reminded that the story of humanity is far richer and far more mysterious than we have ever imagined. In the high plains of Bolivia lies a site that defies easy explanation: Puma Punku. Massive blocks are scattered like a child's discarded toys, but these are no simple blocks. They are carved with incredible precision. Some blocks possess interlocking H-shapes. They fit together so accurately that not even a razor blade can be inserted between them. Modern engineers say recreating this would need computer-guided milling machines, laser cutting tools, yet they were made by a culture with no written language and a culture that had not yet discovered the wheel. Travel to the Inca fortress of Sacsayhuaman, colossal polygonal stones, some over 100 tons, fitted together in a seamless mortarless puzzle, irregular stones perfectly shaped to join their neighbors, the Great Pyramid of Giza, about 2.3 million stone blocks. The pyramid's base is almost a perfect square. Its sides differ by only a handful of centimeters. It is aligned to true north with remarkable accuracy. Stones and internal chambers are cut and finished with extreme smoothness and exactitude. How did they achieve flat surfaces over large areas? How did they cut such precise internal and external angles into the hardest rock? Modern replicas fall dramatically short. Edges are not as sharp, surfaces are not as flat, joints are not as tight. This gap between expectation and achievement remains one of the greatest enigmas, a puzzle written in stone. In the courtyard of the Qutub Minar complex in Delhi, India, a remarkable pillar of iron has stood for over 1600 years. It is known as the Iron Pillar of Delhi. What makes it so extraordinary is its astonishing resistance to corrosion. Any modern piece of iron left exposed to the elements for even a few decades would become a crumbling mass of rust, yet this ancient column remains virtually pristine. Modern scientific analysis has begun to peel back the layers of this mystery. Researchers discovered the pillar is 98% wrought iron. It was forged by hammer welding individual iron blooms together. The secret appears to lie in a thin, protective layer of a compound called mesowhite on its surface. High phosphorus content in the ancient iron, specific forging techniques and cycles of wetting and drying in the Delhi climate. A similar story of lost knowledge appears in Roman structures. Roman concrete, or opus caementicium, was revolutionary. It allowed monumental buildings like the Pantheon, the Colosseum, vast networks of aqueducts and harbors. Many of these, especially those exposed to seawater, have survived for 2 millennia, often better than modern concrete only decades old. Volcanic ash, lime, and seawater. Seawater percolating through the concrete reacts with volcanic material to grow interlocking crystals, especially a rare mineral called aluminous tobermorite. This reaction heals microcracks as they form, making the concrete a dynamic, self-repairing material. The Romans created a living rock that reinforces itself over time. We have identified the chemistry but still struggle to replicate it consistently and affordably at scale. In the year 1901, a group of sponge divers exploring a Roman-era shipwreck off the coast of the Greek island of Antikythera made a discovery that would rewrite the history of technology. They recovered a lump of corroded bronze which at first appeared to be little more than a piece of rock. It was only later, after the object began to dry and split apart, that it revealed its incredible secret: a complex system of interlocking gears. This device, now known as the Antikythera mechanism, has been identified as a highly sophisticated mechanical computer. Using advanced X-ray and CT scanning, the mechanism was an astronomical calculator of breathtaking genius. By turning a hand crank, its intricate system of at least 30 bronze gears could model and predict the movements of the sun, the moon, and the 5 planets known in antiquity. It could forecast eclipses and even indicate the timing of significant events like the Olympic Games. In 2nd century China, during the Han Dynasty, a brilliant inventor named Zhang Heng created a device that could seemingly perform magic, an earthquake detector or seismograph. With 8 dragon heads arranged around its circumference, each holding a small bronze ball in its mouth. Below each dragon sat a bronze toad with its mouth open. When an earthquake occurred, even hundreds of miles away, a mechanism inside the vessel would be triggered, causing the dragon corresponding to the direction of the tremor to release its ball into the mouth of the toad below, creating a loud clang and providing an instant alert. It represents a remarkable conceptual leap, turning the invisible and destructive force of an earthquake into a precise mechanical signal. One of the most famous and controversial examples is the Piri Reis map, compiled in 1513 by an Ottoman admiral. It appears to show the coastlines of South America, and even Antarctica with remarkable accuracy. Antarctica was not officially discovered until 1820, and its coastline was not fully mapped until the 20th century using modern echo-sounding technology. Piri Reis noted he had compiled it from numerous older source maps, some dated back to the time of Alexander the Great or even earlier. The Great Pyramid of Giza is a marvel of mathematics and astronomy. Its dimensions appear to incorporate pi and the golden ratio. Its placement on the globe is uncanny, almost at the center of Earth's landmass. The pyramid's 4 air shafts, once thought for ventilation, have astronomical alignments, such as those in Orion's belt, and the star Thuban, which was the North Star then. Angkor Wat in Cambodia is a stone model of the Hindu cosmos. Its towers and causeways align to solar events. Teotihuacan in Mexico is laid out in a grid that mirrors the solar system, with main temples corresponding to orbital distances of the outer planets. This fusion of science, religion, and architecture speaks of a worldview where Earth and the heavens were intricately and mathematically connected. When modern scientists and engineers, armed with all the resources of the 21st century, attempt to recreate these ancient marvels, the results are often humbling. The gap between what we can achieve with their supposed toolkit and the finished products they left behind is, in many cases, immense. Consider the attempts to recreate the cutting and drilling techniques seen on ancient Egyptian hardstone artifacts. Vases and boxes made of granite and diorite exhibit features that suggest the use of high-speed drilling. When teams have tried to replicate this using copper tubes and abrasive sand, they can indeed drill through granite, but the process is excruciatingly slow, and the results lack the fine precision and smooth finish of the originals. In the 1990s, a team from the television show Nova attempted to raise a 35-ton obelisk using only ancient Egyptian methods. Despite immense effort, extensive planning, and the use of modern ropes and levers for safety, the team struggled immensely, and ultimately failed to replicate the feat with the efficiency and scale implied by the thousands of obelisks and colossal statues erected in ancient Egypt. These experiments do not prove the use of alien technology, but they powerfully suggest that the ancient builders possessed a mastery of leverage mechanics and logistics that we have fundamentally misunderstood or underestimated. These failed or partially successful replications force us to confront an uncomfortable possibility: that entire branches of practical science and engineering may have been developed, perfected, and then completely forgotten. Perhaps they had techniques for temporarily softening stone or acoustic methods for levitation, or a form of concrete chemistry that we have not yet rediscovered. As we stand before these ancient enigmas, we are left with a profound sense of wonder and a necessary dose of humility. These artifacts and structures are not just historical curiosities, they are fundamental challenges to the way we view our own past. They force us to discard the simplistic notion of a linear upward march of progress and to embrace a more complex and mysterious story of human ingenuity. The evidence, written in stone metal gears, strongly suggests our ancient ancestors were often intellectual equals, or better. This reassessment does not require belief in ancient aliens or lost continents. It simply asks us to accept that we don't have all the answers. Perhaps the ancient Egyptians didn't use lasers to cut stone, but they may have developed an equally effective method we haven't conceived of. Perhaps the builders of Puma Punku didn't have power tools, but they may have had a deep, intuitive mastery of stone and of sound. The same intelligence that made the Antikythera mechanism is the same mind that makes the microchips in our phones today. The difference is context, tools, and accumulated knowledge. By studying these technologies, we learn about the enduring potential of the human mind. These ancient wonders inspire us. There are still great mysteries to solve, and the genius of the ancient world may still teach us about our future.